So here we have the 2016, so here we're going to do the 2016 question that came up on statistics. So this was on 2016 paper 2 and it came up as question 9. And the question, I just have it before me on another page. So it says on my computer, data on earnings were published for a particular country. The data show that the annual income of people in full-time employment was normally distributed with a mean of 39,400 and a standard deviation of 12,920. And then it says the government intends to impose a new tax on incomes over 6,000. Find the percentage of full-time workers who will be liable for this tax, correct to one decimal place. So we want to get the percentage of full-time workers who have an income over 60,000. So the information that we're after being given is we're told that we have a distribution and it's normally distributed, so it's going to have a curve something like this, and we were told that our mean is equal to 39, so I'm going to use that symbol for the mean, 39,400, and our standard deviation, I'm going to use this symbol, is the symbol generally used for standard deviation, is equal to 12,920. And if I want to, so what I'm going to have to do to get a probability from, I want to get a probability or the percentage that of workers over 60,000. So what I'm going to have to do is I'm going to have to convert to a Z value. So what I'm going to have to, so my formula, if I want to convert, say, actual figures to Z value, so Z is equal to the figure in question minus the mean over the standard deviation. So I have, so say this is my my diagram. So my mean is always in the middle. So say this is my mean, so 3,9,400, and then this is plus one standard deviation and minus one standard deviation. So if I want to find the percentage of workers. Say this is 60,000 here, 60,000. I want to get the percentage of full-time workers who are up here. So I'm going to get the Z value for 60,000, and then I'm going to find out how many people, figure out what's the percentage above 60,000. So my X is going to be 60,000, and then my U is my mean, so 39,400, and then over my standard deviation, which is 12,920. And now I'm going to use, if I can get my calculator, I'm going to now calculate my Z value. So 6,000 minus 39,400, and we're going to divide that. So we have 60, 1, 2, 3 minus 39,400 over 12,920. And that's equal to, so our Z value is equal to 1.59. I just rounded up to 2 decimal places. So I'm looking, so here I have, say this is my normal distribution, and generally when we have a standard normal distribution we give our mean of 0. So my 60,000 is 1, so say this is 1 standard deviation, this is 2, this would be 3. So my 60,000 is 1.59 standard deviations away, so maybe somewhere around here. And I want to get the percentage of people who are going to be greater than that. So I want to get the probability that Z is going to be greater than 1.59. So the probability that Z is going to be greater than 1.59. But from our log tables we can only get the probabilities of less than. So that's going to be 1, which is the whole of it, minus the probability that it's less than will give me the probability that it's greater than. So 1 minus the probability that Z is less than 1.59. And now I'm going to go to my log tables and get the probability that Z is less than 1.59. So I think it's on page 20 something. So 1.59, and I get 0.9441, 1 minus 0.9441, and then 1 take 0.9441, and I get an answer of I just forgot to bring it, 0.055 0.59. So that's as a decimal. So that's kind of 0. So from that's the as a decimal. So if I want to convert that to a percentage, I'm just going to have to multiply by 100. So it'll be 5.59%. So 5.59% will be liable. And then the question just said correct to one decimal place, so it'll be 5.6%. So that's the percentage of people who will be liable for this tax. So then if we go on to the next part of the question, so I'm going to tear off this page and we'll start on a new one. So so the government will also provide a subsidy to the lowest 10% of income earners. Find the level of income at which the government will stop paying the subsidy correct to the nearest euro. So we say we have our, so that's I'll draw it again. So say we have our standard normal curve and we have our mean here. So 50% on this side, 50% on that side. So the whole, it's 1 or 100%. And the government will provide a subsidy to the lowest 10%. So say if this is 10%. So the government is providing a subsidy to the lowest 10% of income earners. So we want to find what is like the value that which the government will stop paying this subsidy. So we want to figure out what value does this correspond to, this value here. So if we know that we have to convert this from a probability. So this is a 0.1 here to a z value. But if we can't get for our z values, if we have a z value of 0, we'll get a probability of 0.5. If we have a z value if as we increase our z values, the probability start at 0.5. So I can't get a probability of 0.1 from my log tables. But if I get the probability of 0.9, that everything is less than 0. Say if that was, if I get the so say this is the whole of this is 0.9. So if I get the z value of 0.9, then so the probability that if I get the probability that, so 0.9 will have to be the z value that I'm looking for, because what I'm going to say in this one, it's so 0.9 is everything less than. But if I can get, so say if I had the probability, so if I get my z value first for 0.9, it's just because 1 take 0.1 is equal to 0.9. So if I was getting a z value for this, to say everything less than, I would have to get, firstly, I have to get everything that was less than 0.9 and take it away from 1. So the z value that I'm getting is going to correspond to the z value of 0.9. So I'm going to get my z value of 0.9. So the probability that z is less than or equal to z1. So I'm going to first go with a probability of 0.9. So it's 0.9 here. But on this side, so I'm going to get my z value. But whatever z value this is, it will just be minus on this side because it's identical. So my z value for 0.9 is z value for 0.9. So I get 0. So I'm looking for the probability. So I'm going to look for probabilities that's 0.9, and then I'm going to figure out what z value goes with that. So 0.9. So I get the closest one is 0. So it's 1.28. So z is equal to 1.28. So for the 90%, say if this is all 90% here, my z value is 1.28. but we know, so that's just 90, so that's 90%. So, but on this side, it's going to be, say if that was 90% from that side, it's going to be minus 1.28. But we want to figure out what value is literally just the highest value that they're going to stop paying the subsidy. So we want to figure out what value for x gives us a z value of minus 1.28. So minus 1.28. So we're going to let, so our z is equal to x minus the mean over the standard deviation. So this is our z value, and we're trying to figure out a value for x, and we know our standard deviation because we were given that, and it's the mean is 39,400. It's the same from the previous, and then over the standard deviation of 12,920, and then I'm going to multiply across, so 1.28 by 12,920, and then I get a value of, so that'll be minus 16537.6 is equal to x minus 39,400. So I'm going to add my 39,400 on this side, so 39,400 minus 16537.6, and then I get a value that x is equal to 22862.4. So that there is a value that 22862, and then it might say to the nearest euro, so I'm going to put it as 22,862 euros. So that's the level that the government will stop paying the subsidy. So then we're given another question. So then sometime later, so I'm going to tear out this page and we're going to start on another one. So sometime later, a research institute surveyed a sample of 1,000 full-time workers randomly selected and found that the mean annual income of the sample was 39,280. Test the hypothesis at the 5% level of significance that the mean annual income of full-time workers has changed since the national data were published. State the null hypothesis and the alternative hypothesis. So what the mean that, so I'm going to just write down things that I think are important. So the data for full time for people working in the country that I was given at the start. So given at the start, I was told that the mean is 39,400. So that's the data from so that's on the annual income, and then a standard deviation of 12,920. So that's what I was given in the first part of the question. And then it says we have a survey. So then we have a survey, and so n is the number of people surveyed. So n is equal to 1,000, and the mean from our survey. So I'm just going to call this. I'm just going to use that term to for the mean of our survey was 38280. So I want to test the hypothesis at the 5% level of significance that the mean income has, so that the mean annual income of full-time workers has changed. So my hypothesis is so test the hypothesis that has changed since so my null hypothesis is always that nothing has changed. So my null hypothesis is going to be HO that the mean is still so HO is my null hypothesis. My null hypothesis is that since even with this survey that the mean has not changed, so the mean is 39,400, and my alternative hypothesis is that the mean has changed. So the mean is not equal to 39,400. So if I want to maybe figure out how we could make a confidence interval, or we could get our z values for the mean. So because this is we're dealing with confidence intervals for the mean, the standard deviation of the mean is equal to the standard deviation over the square root of the sample size. So this so that's when we have standard deviations for our mean. So square root of the sample size. So our standard deviation is going to be 12,920 over, so the sample size is 1,000. So I'm going to get, so the new value, which is the new mean. I'm going to see what z value that would give if we're comparing it to our original mean. So it's over the standard deviation, which is 1290 over 100. So this formula here was z is equal to, so x, so the mean that we're given minus the mean original over the standard deviation of the sample over the square root of the sample size, because the standard deviation of the mean is standard deviation over the square root of the sample size. So now I'm going to figure out this, and I'm going to get a z value. So I get 38,280 minus 39,400, and then over 12,920 over the square root of 1,000, and I get a z value of is equal to minus 2.74. But I know that, say when I have my standard curve, that for 90%, for a 95% level of confidence intervals, my z values can only go between minus 1.96 and 1.96. And as minus 2.74 is less than minus 1.96, we have to reject we have to reject the null hypothesis. That means the mean income has changed. But there is just another way that we could have done this question. So I'm after getting z values. So we could have conducted a confidence interval. So confidence interval would have been so if we got the mean that from the sample plus or minus 1.96 by the standard deviation of the mean over the sample size. So because this is sample means, so I'm going to put in my sample, so 30, so the mean originally, so 39,400, and then plus or minus 1.96, and then the standard deviation, which is 12,920 over the square root of the sample size, which is 1,000. So plus or minus this, so I'm going to get 1.96 multiplied by 12,920 over the square root of 1,000, and that gives me a value of, so it's 3,9,400 plus or minus 800.79. So 3,9,400 minus 800.79, and that's going to give me 3,859.9.21, and then so that's my lower range. So then I'm going to add 800.79, and then I get 4,0200.79. So that's my range, and now I look for that's my range for my my mean. So now I compare the mean that I got from my sample, which was 3,8,280. So 3,8,280 lies down here, so it lies outside this interval. So we reject the null hypothesis. So the mean income in the question has changed. So, and then the next question we were given is that the research, so wait, is that the correct question? So I'm just getting the next part of our question. So, so then we have question B. So the Research Institute surveyed 400 full-time farmers randomly selected from all full-time. So this is a different question, I think. Oh, sorry, this is for full-time farmers. So the Research Institute surveyed 400, so N is equal to 400 full-time farmers from all the full-time farmers in the country, and found that this, so this is the mean income of farmers, was mean income for this sample. So I'm just going to put X, so that's for the mean income. The sample was 26974. and the standard deviation. So standard deviation was 5120. Assuming that the farm income is normally distributed means it follows a normal curve here. Create a 95% confidence interval for the mean of all full-time farmers. So for a 95% confidence interval of the mean, so it's going to be the mean I got from my sample plus 1.96 plus or minus 1.96 multiplied by the standard deviation of the mean. So it's going to be the mean I got from my sample minus 1.96 by the standard deviation over the square root of the sample size, and then so the mean is between these two plus 1.96 by square root of sample. So the mean from my sample was 26974. So that's going to be minus 1.96, and then their standard deviation was 5120 over the square root of 400, and then and then 26974 plus 1.96, and then 5120 over the square root of 400. So I'm going to get 1.96, multiply that by 5120 over the square root of 400, and then I get so that's 501.76. So it's going to be 26974 minus that, and then 26974 plus 501.76. So then I'm just going to plus and minus that, so it's 26974 minus 501.76, and then I get a value of 26472.24, and then gonna add my 501.76, so I'm gonna add it, and then I get 27475.76. So where our mean should lie within this value, all means should lie. There's most of the mean. So that's our 95% confidence interval for the mean of full-time farmers. And then we are told in the next part of our question that it is known that data on farm size are not normally distributed. So farm size is not normally distributed. So the research institute could take many large random samples of farm size and create a sampling distribution for the means. So the data on farm size data. So if we were to do a graph on farm size data is not normally distributed data, so that's not normally distributed, so that means it doesn't follow the standard normal distribution curve, and then there could take a sample of many and create a sampling distribution of the means. Well, it could, so the sampling distribution of the means, so the mean, the sampling distribution of the sample means always follows a normal distribution. So the distribution of sample means, will be normally distributed. And for those of you that might be interested, this comes under the central limit theorem. The central limit theorem. We don't have to prove this theorem, but we just have to know that the distribution of sample means will always be normally distributed, and that means it will follow that, say we have our mean here, and then that 95, so it will follow, say that between minus 1.96 and 1.96 will contain 95% of all data. So that just means that it'll follow a normal distribution. And then the next part of the question, so then it says, the Research Institute also carried out a survey into the use of agricultural land. So N farmers were surveyed. If the margin of error of the survey was 4.4 5%, find the value of n. So I'm going to figure out how many farmers were surveyed. So I know that one way I can calculate, so the margin of error is, I'll just change my pen color, so 1 over the square root of n. So that's a way of calculating sample size, and I was told that this is equal to 4.5%. So when I first calculate margin, so I have to let that equal to, so a decimal, so 4.5% as a decimal would be 0.045. So I'm going to let this equal to 0.045, and now I'm going to try and get a value for n. So if I want to maybe figure out, I might, what I might do is move my n squared up here and move my 0.045 on the bottom. So 0.045 is equal to the square root of n. And if I want to get rid of my square root, because say if a square root is the same as any number to the power of a half. So if I square a square root, it'll be a half raised to the power of 2, so it'll just be n to the power of 1. So what I'm going to have to do is square both sides, and then I'll just be left with n is equal to. So I'm going to have to square this, so get my calculator, 1 over 0.045, and then squared, and then that is equal to, so n is equal to, so I'll just get 493.827. So to give me a confidence interval of, so if I wanted to get the margin of error to be 4.5%, I'd have to get this many farmers. So I would round up to, so you can't have 0.827 of a farmer. So I'm gonna round up to 494. So that will give us a margin of error of at least of 4.5%. So that's if we're looking to find out how many people were surveyed from a given margin of error. And that is the end of that question, and I hope you found that helpful. Thank you.